Alrighty. Hi everybody. Thanks for joining me on this. What time is it now? I'm in beautiful Bangalore, where it is now 22:30ish. So if you're joining us from Asia, good evening. If you're joining us from Europe, happy late in the afternoon, sort of to you. And then if you're joining us from North America, South America, parts of it anyway, good morning to you. So my name is Josh Long. I'm the developer advocate for the open source Spring technologies at Pivotal. I'm the author of 5 books now on Spring, the latest and greatest, of course, on building resilient, robust cloud scale applications and microservices with Spring Boot, Spring Cloud, and Cloud Foundry. And I'm the leader of 3 instructional videos by Addison Wesley. The latest book is by O'Reilly, but the latest video is by Addison Wesley Pearson, and they're on the O'Reilly Safari Online Marketplace. And the latest one, of course, is a study on building applications with Spring Boot and Spring Cloud and Cloud Foundry. So I'm also a contributor to several open source Spring projects, not the least of which are, of course, Spring Boot and Spring Innovation, the open source workflow engine activity in Vaadin. And I'm very grateful to be here. If you have questions, if you leave this webinar more confused for your time with me than when you came in, please don't hesitate to reach out. I'm at StarbucksMan with an X on Twitter, or there's my email. I am, as always, at your service. I work at Pivotal, and we are a small little startup in the Valley. We started in April of 2013. I work on the Spring team. This is the same Spring team that you will have known and loved for the better part of the last 15 years. And we, along with the leadership on the Apache Tomcat project, the RabbitMQ project, the distributed data structure Redis project, and of course, last but certainly not least, the Cloud Foundry open source platform as a service project, are dedicated to building a modern platform for modern workloads. And we asked ourselves, what can we do to really empower the modern developer? What can we do to help them build applications that work well in the cloud, which of course is where a lot of applications are running today. And so part of that mission was, of course, to make sort of the getting started experience with Spring as easy as possible through, for example, our spring.io/guides and the new website. And Spring Boot itself is certainly a very, very powerful way to be productive very quickly. And another thing we wanted to tackle was, how do we empower developers to build applications that work well in the cloud, since this is the new runtime. That is the new space. That's a new destination for production, right? That's new production. And increasingly, applications, with Spring, we've helped people move away from large, sort of bloated application servers, and we've helped them make these applications as small as possible. And that exodus has turned out to be very, very, very prescient, because of course now we're seeing applications being deployed in the cloud as services, as an ensemble of services, a suite of services. And we're not, I don't think I'm telling you guys anything new. This is not news at all, right? We've seen in the last sort of 8 years or so, we've seen story after story of the big web giants making the move to this new architecture, this new story, right? So of course, lots of different applications have moved from what we'll call a monolithic application. These are large applications wherein all the services and all the functionality are co-located in a giant assembly, a giant deployable unit. Do you guys remember a long time ago in a galaxy far away, there was something called a .ear artifact? And yeah, me either. But it was a way of deploying all your services, all your web functionality inside of a single deployable unit. And we've seen people move away from that architecture a lot in the last 15 years into different small, singly focused services. So Twitter, of course, moved from a Rails monolith and moved to an architecture that is more or less a microservice architecture. Facebook really had a lot further to go because, of course, Twitter reasonably, insanely decided to switch to the JVM instead of trying to repurpose Rails to be the platform that they needed. Facebook, on the other hand, were I guess they were keen on doubling down on their mistakes, so they took PHP and recreated it so that they could build this platform with a runtime that kind of looks like the JVM. Netflix, of course, moved from a giant monolithic application to a suite of microservices. eBay, LinkedIn, Amazon, Google, all of these companies, some a lot longer ago than others, have had to make this jump, right? And that's not to say that there isn't value in this monolithic application. Obviously, if you've got an application to start today, you're not going to leap to divide it into 1,000 different small pieces. You're going to build the smallest thing that could possibly work, and as soon as there's friction, break it up. A lot of people are moving to this sort of architecture, right? And there's a lot of different reasons. I think some of them are fairly obvious. So Moore's law, of course, is this idea that computational capacity will effectively double every 18 months to 2 years. That hasn't been true in more than a decade, but we still think about it as sort of an interesting trend line, right? And of course, in order to build applications that scale today, we talk about process-style concurrency, or concurrency, but especially process-style concurrency. This idea that I want to run more services, not one big one that goes up. We've seen this drive for capacity from mobile platforms. So of course, this number is a very old number from 2012. It's the idea that we have 1.5 million new Android activations every day, and of course, iPhone, which isn't nearly so fast growing, is also growing very quickly, and there's a lot of activations there. So we're seeing a lot of new users and a lot of new people connecting and using apps and making requests for the first time, every day, right? And this number will continue for a while, and even once it's sort of levels off, we'll still have this crazy tidal deluge of mobile-driven sort of users. We have the social world, right? This idea that applications build on top of social networks or social service providers, for example, Facebook and Twitter and so on. Every 60 seconds, these services, and this is, by the way, a graph from 2012, I think. So every 60 seconds, you'll see this crazy amount of activity on these different platforms. And that activity is something that you, dear developer, can harvest, can leverage, can build upon. We see it all the time. Things like Instagram, which often have no redeeming value whatsoever to the world or humanity at large, went crazy big entirely on the backs of something like Facebook, right? We've also seen that things like Farmville, which is a game that went viral because of its integrations with these platforms, can go huge quickly, right? So again, if you're building applications and you're building on top of these platforms, there's no reason your app couldn't also go viral quickly. And all this to say that scale is everybody's problem, right? It's not just the big webs. Increasingly, although it's not as much now, but it's certainly becoming very, very, very prolific a problem, we're seeing this move to the Internet of Things, this idea that every device has an IP. For the 3 billion or so connected human beings on the Earth at the moment, we say that there are about 25 billion devices. This is the number from Cisco, which is pretty darn incredible, right? That's almost 8 devices per human, basically, in their sphere of influence in their lives. And I can easily think about my 8 devices. It's not hard. There are cars now that have IP. So again, this is becoming more of a thing. We're seeing this demand in traffic, and if your application isn't prepared for it, you're probably going to lose out. We're also seeing organizational impetus for this drive, right? Conway's law, this idea that systems are constrained to produce designs which are copies of the communication structures of these organizations. I've heard it alternatively said as a company or an organization that has 4 different teams working on a compiler will intellectually build a 4-pass compiler. You think about Amazon, you think about Netflix, these are not one application. These are, in fact, several different services inside of one web UI, right? And if you think about those different services, they all have different growth rates, different trajectories, different business motives, indeed different, oftentimes, business drivers, right? They may have different teams, different people that care about their investment in that particular feature or that particular service. Amazon, this distinction is far more clear. You go to the website and you can do on the search bar there, you can click the drop down and you'll see any number of different markets and sort of experiences that they expose to people. So organizations are now being increasingly divided up into small business verticals. These verticals increasingly have commingling of business leadership and technology and operations and so on, as opposed to, the tech people over there and then business people over here, and the tech people throw code over the wall to operations, for example. It's not like that as much anymore. So we're seeing a lot of different reasons for this, the embrace of this architecture, and this idea of a cloud native application. And of course, when we talk about that, Netflix famously described the cloud native application as being functional decomposition in terms of microservices. This idea that my APIs, my services themselves, are going to be broken out into process concurrent friendly APIs, and NoSQL, right? This idea that my data can be sharded and scaled horizontally as well, right? So this is part of a larger trend. Today we're going to talk about microservices. When we talk about microservices, there are some rules you may follow. One is that you should embrace APIs. Amazon famously decreed that all their services should communicate via API. That is, no service shall talk to another service's database state. And as a result, they had to do a lot of work to make sure that their applications are available and working, and that their applications are accessible, and that it's cheap and friction-free to stand these services up. Another important feature is this idea of independent deployability, this idea that I can deploy a service without synchronizing or waiting on another team, or at least as much as possible, right? When we talk about independent deployability, despite what some perhaps misguided bloggers may say, we're not talking about DLLs, okay? So just put that one to bed. Okay, so first things first, you want to be able to build applications and APIs as quickly as possible. That should be fairly easy. If you've had a chance to look at Spring Boot, then you know that it's dead simple these days to build an API. So I'm going to go ahead and build a little API here. I'll say hello, Adam, hello.groovy. Okay, and I'll say at REST controller like so. Class greeting REST controller. Okay, and I'll say at path variable. And what I'm doing here is I'm defining a very simple REST API. It's just a service that'll return a sort of a useless message. But what I'm trying to establish here is that if your goal is to get something up and running, and you're scared of having to make everything REST, that friction is long since disappeared. It doesn't cost anything these days to get a service up and running, not even on the JVM. So this is actually a Groovy language script. I'm also going to add. I'm going to use Grab, which is the Groovy language is it's a facility that's sort of like Maven or Gradle. It'll do dependency resolution and bring them into the class path. So I can say I want to use the dependency that has an artifact that is unambiguously resolvable as Spring Boot starter actuator. Okay. And Spring run hello.groovy. And once that starts up, it'll be available. Localhost reservations. Oops. Hi. We said hello. World. Okay. So there we go. There's my little REST service up and running. And that's kind of it, right? And actually, I can go to /metrics. This is by way of the actuator. Let me switch my browser here. Give you a simpler, pretty printing plugin here. Metrics. So I go to metrics and I can get information about the state of the application. I go to trace and I can see the request log. You know, how many requests have been made into the application, the headers and so on. If I go to env, I get information about the system properties and the Java JVM properties. If I go to dump, I get a stack trace. If I go to beans, I get an enumeration of all the Java beans as well as their dependencies. If I go to mappings, I get all the Spring MVC endpoints that have been exposed, their Spring MVC controllers and so on. So again, it's very easy to get applications that you can monitor, to analyze and so on in production. I can alternatively run these as jars. So I can say, hi.jar, and I'll get a jar now. And then it's the same thing as I've just had before. I can say java-jar, hi.jar. That'll start up. And here we are, localhost, hi. There we go. And even better, I can alter things very simply with the judicious use of properties, right? So for example, if you know about Spring Boot, then you know it supports a property called server.port. So I can say java-d server.port equals 8000, for example, and -jar equals demo or hi.jar. And then start that up, and that'll override the default inbuilt properties. So there we are again, 8000, right? So again, it's very, very natural to build services very, very quickly. If anybody tells you otherwise, you can tell them to check out Spring Boot. So that isn't the problem, right? There's no reason you should have any pain building a service today. Indeed, the problem most people face is when they try and get these services to play well together. That introduces fragility. That is where the friction is. And it is because of this that we really, really wanted to sort of take Spring Boot further. How do we build upon that programming model and address the problem space of service resilience? Again, the example that Netflix has is that they've got 600 different microservices, each of which communicates with any number of other services, and they're trying to keep their services and their availabilities as high as possible. Given 600 different microservices, it's a little bit naive to assume that they can keep an SLA, even despite all of them, right? So instead, they plan for software that is resilient to failure. And Netflix is not the only one to have walked this path, of course. Google, of course, had to tread this path from the beginning. Facebook, famously, of course, they had to try and make this work as well. Twitter had to go this route, of course. Taobao, which is an e-commerce engine in China, sort of like Amazon and eBay, except that Taobao makes more money than Amazon and eBay combined by a lot. And Baidu, which is a search engine that serves 700 to 800 million people in China, and making it the third largest search engine in the world. And of course, Netflix, which in the primetime evening hours in the United States accounts for something like 80% of the internet traffic. These are all companies that have also had to make this trek, and they've done so on top of Spring. And invariably, when you talk to them, you discover that they had to build a layer on top to address these problems. And so we're great admirers, for example, of Netflix. They've built a lot of great stuff, and they've open sourced a lot of it. And we use that as an inspiration when we built something called Spring Cloud, which integrates a lot of those pieces as well as pieces from other technology stacks. So what we're going to look at today is specifically the bits inside of Spring Cloud, again, ignoring a lot of the other features that Spring Cloud provide around security and distributed configuration and messaging and all that. We're going to look specifically at the bits that can help you build robust service-to-service interactions, okay? So we're going to look at a project here, and by the by, just so we're on the same page, you can follow along at home. Again, the code is on my GitHub, github.com//long/beautiful-microservices, okay? So the code is all there, albeit in fully fleshed out form. What I have here is but a skeleton, a husk of what we need. I'm going to stand up a configuration service. This is just a sort of a proxy for configuration files. By that I mean YAML files, okay? And these YAML files live in my home directory, and they're under a directory called Beautiful Microservices Config. That repository, if you like, is also available on my GitHub repository, on my GitHub account, and so you can clone those as well. I won't spend too much time looking at these configuration files, but suffice it to say, I'm not keeping the configuration along with the modules here, because it's a good way to decouple and decouple the configuration from the applications that consume it. This is better introduced in a previous webinar I've done on Spring Cloud, and of course the reference documentation is second to none. And there's a blog you might check, if I may so humbly recommend it. It's one that I wrote a few months ago called 12-Factor App Style Configuration, and it drives home the point here. But the point is, I've got it in this application, this ensemble of services, and I need to stand up that configuration server. So I'll do so. Spring boot application @enables config server. Oops, I think it's already running. Ruh-roh. That's not good. Okay. I started 2 of them, I think, so I'll just run again. And then from here, we can fairly well ignore it. First thing I need to do is stand up what is a phone book, a service registry. The idea is that I want my services, which may grow to any number, to be able to discover each other, right? And in order to do that, I want them to be immune to topology changes. For example, in a cloud environment such as Cloud Foundry or Heroku or OpenShift or indeed just Amazon Web Services directly, services are ephemeral. They come and go as capacity dictates, and where they live isn't so important as the fact that they're available, right? So that bit of decoupling is typically accommodated through something called a service registry. There are several different options out there. Netflix have something called Eureka. Eureka is their service registry. It's very, very simple to use Eureka in your application. So we're going to go ahead and set up an instance of it here. You need to get Eureka proper, ignoring the configuration bits, and that's story for another day. But to get Eureka proper, you need Spring Cloud Starter Eureka Server, and then you need a public static void main. You'll say Eureka application, for example. Okay, and I will cheat here. So that's what it looks like. Oops, don't even need that. Okay, so there's my Eureka application. It's going to stand up a service registry. Again, this is the important bit here, right? This is the one annotation I need, and it's going to stand up the registry based on Netflix's Eureka service registry. There are other options like Consul from HashiCorp, the company that makes Vagrant and Surf and so on. And there's also Zookeeper, Apache Zookeeper, which is a very, very prolific coordination registry, very, very good as well. And they're all available in highly available modes. In our case, I'm just standing up one instance of Eureka. You'll see as we work with it that it doesn't like that. It's going to encourage you very loudly to reconsider the folly of your ways. So 8761, there we are. So there are no services available here. Okay, I haven't registered anything yet. I haven't started any services yet, so that makes sense. Other than that, though, this is pretty basic, wetware friendly UI. There is also a REST API. This is an indication of the not liking my non-highly available configuration. The exception you see here is from the is replica available thing, and then it blows chunks. This is a wetware friendly view of the data, but there's also a REST API for machines. Okay, and there is let's see, is it Eureka.xml? I forget, but there's an endpoint you can consume as well. You won't have to deal with that endpoint directly, as we'll see, but it is there, right? So this is an API, and services are going to register themselves in it and they'll be just able to discover each other by service ID here. So about those services, our first one is going to be a bookmark service. This is a service that will maintain a collection of bookmark data for us. Again, not particularly fascinating, but I just wanted to have two different APIs that will connect together later on. The Bookmark Service is a pretty boilerplate Spring Boot application. So we'll say bookmark application, like so, and Command J, BM bookmark Java. What you see here is a fairly, again, pretty mundane, right? It's a public static void main, so I've got Spring application.run. This is Spring Boot. I'm using the Spring Cloud application annotation, which is to say I want this application to be a Spring Boot app. I'm going to enable the circuit breaker and the discovery client. This is the client-side API for our service registry, in this case, Eureka. I have a command line runner here. The command line runner will start up. Excuse me. This command line runner will start up, and it will create a bookmark for every user. So this collection, this code here, will simply iterate through these 5 different names, and for each name, user ID, it'll create a bookmark object for that user. So I'll have 5 bookmark objects in my database, which in this case is a H2-based database, and I'll be using Spring Data JPA to save everything off. And I've got a REST controller that'll export the bookmarks under the user ID / bookmarks. Okay, and that fairly mundane, just a JPA entity, nothing particularly fancy. So let's run this. It will register itself in the broker using the name it has been given in the bootstrap.yaml properties file. Now this is a Spring Cloudism. This is very similar to Spring Boot's propensity for loading application.yaml or application.property. Spring Cloud will load bootstrap.yaml or bootstrap.properties. This is a file that gets loaded before the application equivalents, and that's because, for example, these values, for example, the Spring Cloud config URI path, are needed for Spring Boot to load properties for the rest of the application to be configured. So again, don't dwell on it too much, but all we care about is that this is the ID of the application. And if we revisit Eureka, we'll see that it is, yes, very, very unhappy, and it has been registered. So the application is here, Bookmark Service. I can run another instance of the Bookmark Service, and again, the reason I can do that is because I have not configured a server.port by default, and it's going to the config server and it's looking for configuration. And the configuration, for the Bookmark Service doesn't specifically specify anything for a port, so it's going to drop through to the default, everyman's property file called application.yaml, and there I'll have a property called server.port, which says if there's a port variable, prefer that. Otherwise, sort of a nested if-else. If there's a server port variable, prefer that. Otherwise, 0. And 0 in the case of Spring Boot means just assign me a random one. So I can get away with this chicanery on my local machine here. So I'm going to run it again without any worries of port collision. And when we do that, okay, in a few minutes or a few seconds time, we should see the status here, which is up 1, increment from 1 to 2, right? That's pretty natural. The response is 200, so you can see it's already talking to Eureka using the heartbeat. We just need for it to reflect here. And this information is valuable because now, I want to be able to get all the instances available for that service. There we are. See, it says Discovery Client Bookmark Service, re-registering apps, Bookmark Service, registering service, registration status 204. And that's interesting. I never actually tried it from the same node. I know it works on multiple nodes because it definitely works from there. Oh well. So I guess that doesn't work on the same node anyway. But anyway, the service is up. There's the one that we wanted to talk about. Good. I've killed both of them in this case. Rerun that, and then we'll move on to the next service, which is the contact service. And the contact service, very much like the bookmark service, is just an API that'll hold all of the contact information for different users. Okay, so I'll reinstate this module here, contact service. I'm going to add a contact application. Okay. And good. There we go. So there's the contact application. It's the same thing as before. I've got a command line runner. It'll start up when the Spring Boot application starts up. It's going to go through this collection of user IDs, and then for each user, it'll create 1, 2, 3 different contacts, you know, sort of like a phone book, an actual phone book, for each of these 3 different names, and I'll save it in the database. Okay, so now the only thing I'm going to use to correlate the request between these 2 services is the user ID. The contacts and the bookmarks are both collections underneath the user ID root. Okay, again, if you're using in a more production-oriented system, you'll use something else besides the user ID in the URI paths for correlation. You might use, for example, in the case of a user context, you might use a Spring Cloud security access token, right, which is an OAuth access token that Spring Cloud and Spring Security OAuth can make dead simple to both stand up, produce, and consume. Okay, so that is here. Let's run this. Bookmark service is back. Fantastic. The contact service should be up and running. Taking this up and running. Here we go. And give that a second. We'll see it available. The contact service, just like the bookmark service, exposes contacts underneath the user ID. So the bookmark service is under user ID / bookmarks. The contact service is user ID / contacts. As I say, these are forced engineered coincidences. You might use an access token later on. But in every other respect, these services know nothing about each other, right? This is very common in a service-oriented world. You might look at, for example, all the different services that sign in with Facebook. You know, they don't actually have their own sort of ID or notion of identity for you as a user. They have the ID that they're sharing with Facebook, or by extension, the access token that they're sharing with Facebook, which is as good as an ID. So now both the bookmark service and the contact service have automatically registered themselves. The way that they're able to do that is each one of these modules, again, very, very simple Spring Boot style services. Here's my web support, my configuration client support. We don't need to visit that, but Spring Boot support for JPA, the actuator bits for the management and metrics endpoints, and Eureka in particular. This is the Eureka module, the client-side support, right? Before it was Eureka server, here's Eureka. This is going to provide a Spring Boot auto configuration that will take the current application, spring.application.name, contact the Eureka service registry, and again, it's going to do that by looking for the configuration it's got in the config server. In this case, I've got, you know, all my nodes that will need to talk to Eureka are going to need the same value, so I put that in application.yaml, and then all my services share application.yaml, and they're going to call Eureka client service URL default zone, and this is the, you know, property placeholder resolution mechanism that's going to be used to locate the registry. I'm going to either try and resolve it via this environment property, or if that property is absent, this literal localhost :8761. Okay, so that's how I'm guaranteeing that each Spring Cloud microservice is able to find the registry to register itself with. Once that's up and running, I will also have the ability to, for example, in my code, inject in each one of these services. I can actually inject a void set instance info. Right, for example, I'm using Eureka in this case, and I can use the info to get metadata. You know, I can actually set values in there, or I can read values, right? This is the object that Spring Cloud is going to configure this for this specific instance, for this specific node. I can actually add metadata. I can say, oh, well, you know, cookie or something like that, or whatever I want, right? I can say I can add metadata to the registry that I can then query later on, right? So this is actually a very, very powerful pattern, and I can use that metadata to sort of demarcate the kind of service that a specific node supports, or the role that it plays. Okay, now let's finally build a passport service. Our passport service will be, it'll be a client, sort of an aggregation point for our Spring Cloud microservices. The passport service will work with both contacts and bookmarks. Okay. And it's fairly straightforward, BM, passport Java. There's actually a fair amount going on here, so we'll walk through it one by one. What I'm trying to do, what I'm trying to demonstrate, is how to consume other services, okay? And so I've got, it's a Spring Boot and Spring Cloud application, of course. I've turned on Netflix's Feign and Zool. We'll come back to both of these in just a minute. But other than that, it's, you know, it should look fairly familiar. What we're going to do is we're going to use that command line runner. Remember, this is the interface that I showed you earlier. It has one job, given the public static void main string argument array that gets passed into the run method, do something, right? And this gets called after the Spring application has started. If initializing bean is a way to configure a bean after it's been configured, command line runner is a way to do processing after the application has been configured. And so it's a great place to put some demo code. So the first instance of the command line runner that we're going to have here is something that uses the Spring Cloud Commons discovery client. Now again, the discovery client is the client-side API. It's an abstraction that's common to all the different supported service registries that Spring Cloud knows about. And it allows us to ask questions of the service registry. So in this case, we're going to get an implementation, and in fact, you can guess which one it is if you look at the available implementations on the class path. We're going to get an implementation of Eureka discovery client. Although we don't know that, because at runtime we're going to have the interface type. If I were using Spring Cloud support for Consul, I would get that implementation. If I were using Spring Cloud support for Zookeeper, I would get that implementation. If I were using Spring Cloud support for the Lattice distributed runtime, I would get that implementation. Or for Cloud Foundry, I would get that implementation, etc. And once I've done that, I can make calls against the discovery client. I can say discovery client.get instances. This returns a list of service instance objects, and those service instances are, you know, again, that's an interface. So I'll get an implementation specific to Eureka or to Consul or to whatever, and I can ask questions like, what is the service ID, the host, the port, etc. for a given service, and I can articulate information about that service. So here we go. Okay. So there we go. I'm going to print out for each service. I'll print out the host, port, and so on from the service registry, the phone book, if you will. Okay. And of course, in our case, we've only got one registered instance of each. So you'll see only one entry be printed out here. Okay. Small screen, long line of code. First world coder problems. Sorry about that, folks. Okay, here we go. So that'll be the first thing we can see. That's a programmatic way of asking questions about the topology of the cluster. Is the service available? If so, how many instances are there? And you know, what other metadata can you give me? I can, of course, downcast my service instance to a bean of type Eureka service instance if I know that that's the type I got. That, you know, that's the type I'm going to get. Moving up sort of the abstraction hierarchy a little bit, let's turn to, instead of manually extracting the host and port and then feeding that into some other communication mechanism, we understand that in this case, I'm trying to make API calls to another REST service, right? So I don't really need just the host and port. I just want to make a REST call. And I have, of course, Spring's REST template, which makes dead simple common HTTP calls, right? GET, POST, etc., or the more general purpose exchange, which lets me make an HTTP call against a REST service. So I'm going to use the REST template. It's it's got the ability, you can configure interceptors, and those interceptors can pre-process and post-process HTTP requests. And Spring Cloud will automatically configure an interceptor that will look at the URL that we're trying to make the call against, and then see that we're actually not referencing a host here. This is bookmark-service. This is a service ID, and indeed the same service ID as we have in Eureka. Okay, so it's going to pre-process this. It's going to pluck that out. It's going to call Eureka, and it's going to get back a collection of service instances. In our case, we'll only have one, but as you register more and more, you'll get 10, 20, 100, whatever. And then it'll try and pick from among those instances the best instance to respond to the call, and then it'll forward the request to that instance. Now, this is, of course, a very important point. How does it determine which instance to use? It's going to use something called Ribbon, also from Netflix. Ribbon is a software-defined load balancer. It provides the ability to, in code, apply some sort of heuristic to pick from among a set of instances. There are a lot of reasons why you might do this sort of routing in the client in Java code, as opposed to perhaps at the big five router, F5 router. Most of the reasons that I can give you center around the idea that the client is in a better position to respond to the unique oddities of topology changes, not the router, right? And the client and the code are in the best position to change it and make sure it works accordingly, right? Keep the code, keep the routing rules in the application itself. Indeed, I may consume an application with an entirely different pattern than some other applications. Same API, but different use cases, different sort of routing rules. And Ribbon has lots of defined heuristics. By default, we're going to get one that's going to give us a round-robin dispatch, but I can plug in my own. And I might, for example, use one of the out-of-the-box routers. I might choose, for example, to care about availability zones, or I might decide I want to have a router that routes calls to a specific cluster of services or to a specific data center or whatever, right? Or I can pick something else. I might have some concept, again, predicated on that metadata map, for example, perhaps, that says that this node is a master and that one's a worker or something like that, right? Again, that is entirely up to you. You can override the algorithm that Ribbon uses by overriding the load balancer client object that Spring Cloud automatically configures for you. So again, this is a regular Spring Boot-ism. It's a bean that has a conditional on missing bean annotation. So if you define a bean of the same type, that'll be preferred instead of this one, and that's what will get passed into the REST template interceptor that eventually processes this call. Other notable things, of course, is that we're making a REST call. I'm making an exchange call. I'm asking it for a list of bookmark types back. Note that this bookmark is the same. It's not the same bookmark as we saw earlier in the bookmark service. It's a type I have in the same code page. It is not a JPA entity. It has nothing to do with the other type. And that may, that's because my other service may, for example, be implemented in, might not be using JPA. Who knows? My other service is just, as far as I know, I just have JSON. So this is the type I want to map the JSON structure to. You could, of course, if you have a more homogeneous environment, keep the types, the sort of DTOs, if you will, in a separate jar. People keep asking about that. But I would try not to do that first. And only if you have to, then do it. Right, so moving back up here. The information I want is I want a list of bookmarks. We know that that's what I get back if I visit the Passport service. So for example, if I go here, or rather if I go to the Bookmark service, I go here, and then I go to pweb/bookmarks. I get, one I get a collection of one element, this one element here, for the pweb link, and I want to get that in a list, right? I have to use a hack. This is a sort of a nasty thing that we have to do in Java because of type erasure. This is an implementation of the pattern called the type token pattern. Java doesn't have the ability at runtime for an instance variable to, through reflection, tell you what its generic type is, right? So this list of bookmark, that disappears. At runtime, Java thinks that this parameterized type reference object is a parameterized type reference of nothing, or of object, or if you will. I mean, there is no generic parameter here. It's a compiler time only piece of sugar, if you will, a feature. So in order to circumvent that, we can create an anonymous inner class. Subclasses, that is to say, if I said class X extends parameterized type reference of list, like this, like that. If I did that, that actually retains its. I can actually ask the instance X at runtime what its generic type is, and it'll be able to give me that information. So I'm doing the same thing here. I'm creating an anonymous subtype, and that's the pattern, right? If I remove it, in fact, the Spring parameterized type reference implementation of the type token pattern won't even let me compile. It's abstract, so it requires that it be a subclass. Okay, and then I pass that response type into the exchange method, and Spring MVC REST template, and we'll pass it into the Spring MVC message converters that it has configured on the client. It'll say, oh, well, we want to get a list of bookmarks back. Can you think convert this buffer, in this case JSON, into that object? The Jackson message converter will kick in, and then it'll give us a response entity with a payload of type list bookmarks. Okay, so this is the body. That's the list of bookmarks, and I'm just going to print them all out here. Moving further up the stack, I'm going to use Feign. Feign is Netflix's declarative REST client technology. It's sort of like the Spring Data repositories. It's based on interfaces. I can declaratively describe the contract for a REST service. So here I'm saying, here's a Java interface that will be a client-side representation of a REST service. And when I'm going to use the Feign client annotation, I'm going to plug in the bookmark service. I'm going to specify that I want to use the bookmark service as discovered from Eureka. Again, it'll look up the instances from Eureka and pass them into Ribbon. I want to use that service to handle this request, and then I want to call /user ID /bookmarks. And for the user ID parameter, I'm going to pass in the get bookmarks user ID parameter from the method. Okay, so same thing for the contact service. Here, you have almost no idea at all from the consumer perspective that this is HTTP. This is actually much higher level than the HTTP-centric REST template and the low-level discovery client-centric approach down here, right? And we've gotten, you can choose whatever approach, whatever granularity works best for you. The result will always be, it'll work either way. You'll get the result if you want. There's no reason I couldn't have taken the discovery client and extracted the host and port and then built up the URL and plugged that into the REST template, for example, right? Okay, so let's start this service up. Up and away. The service is also I've also exposed another REST endpoint on this service. It's called the PassportEndpoint. And the point here is to in one place, return an object that has both the user's contacts and the user's bookmarks. It's a sort of passport object for contacts and bookmarks for this user. And I'm doing this inefficiently in the name of simplicity of code and in the demo here, but I would recommend for anything non-trivial, make these two different calls, which are of course network hops, concurrent, and you can very easily do that using something like RxJava. So I can use RxJava to say that I want this call and that other call to happen concurrently, and then I want to zip and then process the results at the same time, once they're both returned. So I'm going to use that endpoint here. I can go to Eureka and find out that the passport service is now up and running. It's on port 50717. and I go to JLong passport, or pweb, if you will, or desire. So again, behind the scenes, I've got bookmarks. That's a REST call to the bookmark service. And I've got contacts. And again, the contacts are coming from another service. I'm getting results here in a sort of aggregate entity called the passport. But there's no reason this couldn't have been adapted and transformed either, right? That's certainly true. So I want my services to be resilient to failure. So for example, what happens if I go to the bookmark service and there's no service available, right? I don't want it to just blow chunks and throw its hands up in the air and quit. So instead, I can use Hystrix. This is a implementation of the circuit breaker pattern, and this implementation in particular is from Netflix. And it's basically going to wrap this method around with a little stateful, state machine, with a little state machine that's going to say, okay, well, the last attempted execution of this method, invocation of this method, create an exception. If it fails n more times, then quarantine it. Make it so that nobody can call that method directly anymore. Instead, route traffic to the fallback method. So the fallback method here is get bookmarked fallback. It will simply return an empty array, empty a list of bookmark in this case. There's a gentleman out of the UK named Fred George. He gives a great talk about this. He describes the human body as a microservice system, and he gives this great idea that he has this great suggestion or illustration. If I cut my hand, I don't want the whole body to just blue screen, right? I can degrade gracefully. I may bleed locally, but the whole thing doesn't just stop working. And your system as a whole should be similar to that, right? So here, if something goes wrong, I'll get a default. If the Netflix search engine is down, for example, I may get recommendations instead, but I'll get something. That's the point. Okay, so this code, of course, is in my integration client, and the integration client is what I'm using in my Feign example. I'm sorry, in my Passport REST controller. So the REST controller is injecting the integration client. The integration client is using the Feign implementations, and I've got two different methods that make potentially shaky network calls using the Feign clients, and if something goes wrong, they have backups. I also have up here, you'll recall, the Zool proxy. Okay, so Zool is an API gateway. So I don't know how good you are with your mythology or your Ghostbusters lore, but Zool is the gatekeeper. It's this guy right here, and it's the creature that it's the gatekeeper, right? And this is Zool in Zool in the Spring Cloud Stack is a implementation of the micro proxy pattern. It's a reverse proxy that acts that sits at the edge of a service API, something that you'll expose to clients like a mobile device or an HTML5 device, and it will take requests and proxy them to backend services, like for example the Bookmark Service or the ContactService. So I didn't have to do anything to get it working besides saying @enable Zool proxy. It'll automatically talk to the service registry, in this case Eureka, or Consul or Zookeeper or whatever, and make those services available underneath my roots of my Passport service. So I can go now to ContactService /pweb/contacts. Did I make a mistake here? ContactService. There we go. I was in the wrong instance, wrong service. So here is the contact information coming from the backend contact service. If I go to Bookmark Service, bookmark. So again, this part of the request is what I would have sent to the Bookmark Service root if I were talking to that node and that host and port directly. But remember, I'm on my Passport service here, so I have to specify the service ID as the root here. And this is very convenient. For example, if I have an HTML5 client or something that has to run. It can't run afoul of, for example, class origin request forgery restrictions. And I don't want to retrofit every one of my existing microservices, my backend mid-tier microservices, to be aware of the nuances of each client. So instead, what Netflix does is they stand up an API gateway, an edge, a microproxy like Zool for every one of the clients. That way, even if they've got 600 different mid-tier services, the edge services are the ones that clients send traffic to. And the edge services are not discovered through Eureka. Those are stood up and made statically available through DNS. They don't, you can put those and route those and load balance those in your router. But the requests that those edge services make to the mid-tier services in the background, those are resolved through Eureka, okay, or the service registry. So I've got two different ways of consuming these backend services. As we've seen, I've got the Zool proxy in play, and I've got my Passport service, which aggregates and consumes both backend services using something like Feign. What happens, we talked about that circuit breaker. What happens if the bookmark service is gone, for example? So if I go to the bookmark application and I'm going to exit it, I'm not sure if you can see that on your screen here, but I'm hovering over the exit icon in IntelliJ, so goodbye to bookmark service. If I go to Eureka and refresh, you can see it's already been deregistered from the registry. And now if I hit refresh on the service, you can see that I get an empty collection back. Right? So that's exactly what we want. We want it to be resilient to topology changes. Okay. I have, of course, I want to see what's happening here. So I want to be able to get a dashboard perspective of what is happening. For that, Netflix have made it very easy to stand up a dashboard. It's appropriately called the Hystrix dashboard. I'm going to go ahead and also stand that up. Here we go. Okay. Good. And it's just @enable Hystrix dashboard and run. This will let me specify the individual node that has the circuits, in this case our Passport service, and then I can ask it to consume the server sent event stream called Hystrix.stream that's being emitted from the Passport service. And if I go to my browser, for example, here's Hystrix.stream. Right, and it'll never finish loading, right? It is by definition an unending stream of data. So I'm going to tell Hystrix about my service. It's on port 50817, localhost 50817 /hystrix.html. And I'm going to specify where to find the stream, okay, in this case from the Passport service. So I hit monitor, and you can see it's got an idea of the circuits in the system. So get bookmarks, and then get contacts down here. Let's see if I can show both of these in action. So get bookmarks, get contacts. Here's my Passport. It has both bookmarks and contacts. Of course, I've since taken the bookmark service offline. If I hit refresh, you'll see that as I hit refresh, I'm not sure if you can see it on the screen, but I'm hitting refresh fairly heavily on my Passport service here. As I make requests, the traffic spikes up here, and you can see that the get contacts circuit is working just fine. It's a moving average, so as I lay off the gas, the traffic drains down. But the get bookmarks circuit is in trouble. It's open. And again, this makes sense, right? It's very much like a circuit breaker in a house. I'd much rather lose the lights than the house because of a fire. If I bring back the bookmark application, like so, hit run. Eventually, that'll re-register itself in Eureka, and as soon as it does, I'll be able to hit refresh and see that the circuit has been closed again and everything is hunky-dory. This is a node-by-node view, but I can use something called Turbine, and Turbine will aggregate a set of different streams and then present them to me in a single dashboard for an ensemble of services. So with that, I think we've covered a lot. We've looked at using Spring Cloud to consume services simply with the likes of things like the REST template integration with the discovery client. We've decoupled topology from availability using service registries like Eureka and Consul and Zookeeper. We've made our services more robust to outages using the circuit breaker pattern, for example, and service registration and so on. I didn't show you reactive code as you might implement it with RX Java, but that's definitely something I encourage you to check out. We could and probably should do a whole webinar on just that. If you have, a couple of takeaways, of course, is that scale is everybody's problem, not just the big web giants. So that's a good thing and a bad thing. It doesn't have to be scary, though. There are primitives and tools to help make that journey much easier. Cloud native is, after all, the new norm. I think you'll agree Spring Boot is a darn good way to build an API and stand that up and get it in production and monitored. Spring Cloud simplifies the integration and interactions between those APIs. If you're running this stuff, I of course, without hesitation, would recommend a cloud of some sort. You'll note that I didn't use a cloud here, but all of the code on GitHub has the appropriate manifest, for example, to get this running on Cloud Foundry, and I'll very shortly have the appropriate configuration to get it all working in a Dockerized scenario as well, because it just makes sense. This is elasticity. You want to build for elasticity, and you want to give yourself the environment that will give you that elasticity, and that is today a cloud. Smaller is more, less is bigger, and always aim for the small thing that can possibly work. And as you can see, it doesn't have to be complicated, even if you have lots of little things. And the benefits outweigh the potential confusion. All right, thank you very much. I'll take some questions now. I am, as always, your servant. If you have questions, don't hesitate to reach out to me on Twitter at StarbucksMan, that's BUXMAN, or at my email, or Spring Central, of course. I mean, we're all very happy to hear from you. The code I've talked about is on github.com/Josh Long, and you'll look for Beautiful Microservices. The Spring Cloud project is itself a separate organization, so github.com/spring-cloud. There are innumerable many great guides on spring.io/guides. We've just added, in fact, a guide on using Docker with Spring-based and Spring Boot-based applications, and another one on using the Lattice distributed runtime. Think of it more like a Kubernetes or a Mesos. It runs containerized workloads like Docker. And that's, if you want to find out more about that, check out lattice.cf. All right. Peter, what do you think?
Awesome. All right. Hey, did you say the URL was github.com Josh Long Beautiful hyphen microservice or microservices?
I think it's microservices. Great question.
Okay. Hold on. I'm just checking.
I appreciate that, good sir.
And it is. It is microservices. Okay, very good. All right, cool. I just, a couple folks were asking for that. Artem, there you go. Okay, great. So we had a bunch of good questions here. First up is Ben Zhang asking.
Hi, Ben.
This was just about 10 minutes ago that he asked this. And he says, hey, if it's the right choice to pass dynamic data between services, such as how many books are left at my service, if the service doesn't share the database, what do you do, right? Because this is the whole eventual consistency thing with microservices, right?
So you ask the API. If the service doesn't pass the data, say that again. Maybe I misunderstood the question. It seems a little.
So I was trying to paraphrase because it's not straightforward English, but let me read it literally. If it's right choice to pass dynamic data between services, such as how many books left at my service, if the services don't share the database.
Yeah, it is definitely. That's absolutely. I would pass that information through the API. You want to keep yourself, again, slight pain in that you have to actually send the stuff across the wire. Huge gain because now your services can be implemented in the choice and the best choice for that particular service. My database selection today may actually be the same as the selection for another service, but I may want to move to a different database tomorrow. And additionally, I want to be able to change my database and my schema without having to synchronize with everybody else. So that decoupling is very, very important, especially as you move to scale. There's this idea of a bounded context. If you ever read Eric Evans' amazing domain-driven design, he talks about a bounded context for services and distribution of responsibilities. I recommend diving into that for a deeper discussion.
Awesome. Another question from Ben. When a service is not down but off the network, the registry service will heat. Wait, hold on. Let me see if I can figure out what he's trying to ask. Sorry, hang on a second, Josh. So when the service is down but not off the network, registry service will something beating the service and update the registry. There's a typo in here, but I'm having trouble. I think what he's kind of getting at is how is the registry kind of service dealing with unavailability? I think
right.
Yeah,
so
he meant heart beating. He meant heart beating. Okay, sorry, I just figured it out.
Right.
There we go.
There's a heartbeat. If you have, so again, the service registry is ideal for that. If you have network partitions, which is going to happen, right? There is a heartbeat that it goes on between the clients and the registry, and eventually it'll be decommissioned. This is true for it's one of the very, very, important principles of all the different service registries. So eventually it'll be decommissioned. How soon it will be decommissioned is configurable as well. In my case, everything is the default, so it's about 30 seconds for registration, 30 seconds for heartbeats, 30 seconds for whatever. But you can fine-tune all that by looking at the properties.
Awesome. Very cool. Let's see. Roberto, your question, what if we use more than one instance? Could you just add a little more context to that so we know specifically what you're referring to? Thank you. Let's see. Stacy Pierce asks, when you externalize properties, it was noted that you had a shared application YAML. Do you externalize the properties for each microservice in a separate repo, or how do you recommend managing?
So the configuration here in my Spring Cloud config server, which I didn't really mean to dwell on in this webinar, but thank you for asking. It's stood up externally in a single Git repository. Each service, as identified by their appropriate bootstrap.yaml Spring application name, loads the configuration from a configuration file with that same name. So, for example, my Eureka-service.yaml in the Git repository is going to only be read by the service that identifies itself as Eureka-service. Same for ContactService, same for Bookmark Service, etc. There's also, this will be loaded with priority, but every service will also get application.yaml. So application.yaml will be loaded first, and then specifically based on the ID, this one will be loaded second. That's the Spring Cloud config server. There's actually a whole lot of other great stuff you can do with it. You can actually encrypt passwords, for example, and specify a key on the server, and then in the client have that decrypted in memory, in transit, in flight, as opposed to storing passwords in plain text. You can lock down the GitHub repository, of course, and lock down the config server itself using HTTP basic. You can actually support multiple Git repositories now. That's actually due to a contribution from our pals at Ticketmaster in Spring Cloud config server. So that's a whole other webinar. I did a blog on that 12-factor application style configuration, but I smell a second one coming on.
I've already linked to that twice. I did it early on at the beginning of the webinar when you mentioned it, and I did it again in response to this session.
Dude.
So the link to it is there.
Cool, thank you.
You're welcome. You're welcome. I'm going to skip over one question because there's one that I'd like to see, one that I kind of want to go out of order here and address this one right away. Ken Blair asks, well, Spring is sometimes referred to as heavy due to size. How does that play in these services, in particular compared to Juice, Jersey, etc. on Netflix open source?
Well, the people that say that I think are I don't think it's particularly controversial to suggest that the people that say that are the people that have an interest in making Spring fail. Spring isn't particularly heavy. Again, each one of these services is using an embedded web server. I can use embedded Tomcat, embedded Jetty, whatever. That's the same trick as, for example, something like Drop Wizard is going to do. And again, embedded Jetty is embedded Jetty. It weighs so much. You can use Jersey if you want with Spring, actually. We have here, go to start.spring.io, and you'll see that everything's a la carte, right? I'm not deploying this to a Tomcat or to a WebSphere or Web JBoss or whatever. I'm choosing the bits I want and nothing more. So if I wanted to use Jersey, I could. I don't recommend it, again, because you're missing out on a lot of the features that a full-fledged MVC and REST technology as you might get from Spring MVC offers. But again, that's there. Again, you don't need anything but what you need. If I want to just use the web support and that's it, I can hit Java 1.8. Great, and the web support is going to bring in the embedded web server. That's going to be Tomcat again. And I hit generate. If I want to actually have integration with production and the actuator endpoint, that's trivial, so I can do that. There's another one. Again, it becomes very, very small because it is just pieces. It's just the code that you need a la carte. Actually, if you look at my jar here, that's 22.6 megs. That includes Tomcat in this case. You can use Jetty, but I think most people would be surprised to know that Jetty is actually a bigger jar footprint than Tomcat. And you can actually use Undertow from Wildfly, from the Red Hat one. So this jar, if you recall, this is what I looked at when I created that Groovy script before. Again, in terms of heavy weight, I don't know what that is. I don't know how to respond to those kind of accusations because, if you remember the jar that we created in the very beginning, it was, where did I put that? Right here. It was a pittance in terms of actual code. And then the footprint was, again, it's just the web server and that's it. I mean, Spring MVC is just a few hundred kilobytes. So that's as small as it gets, man. You can do CF push and push that into the cloud and you're up and running. These features don't have to be excessive at all. It's only as big as you need it to be. And that's the whole point of microservices. You want to decouple this stuff.
Right, and you need something. It helps to have something that's modular because your microservice isn't trying to boil the ocean, right? It should be very tightly scoped, a la domain-driven design, single responsibility principle. So your list of dependent jars should be, as short as you can make it. And at 22 megs, that's pretty short. I mean, memory in the cloud's cheap, and certainly disk is. That's not a particularly there must be some other meaning that, I don't know, it's either FUD or they have some other meaning that we're not able to decipher. So if you know what that is, Ken, please let us know. In the meantime, a couple of other questions. Corey asking, I think I did jump ahead. Ben, I know you had one or two questions that I haven't addressed yet, but you've gotten a couple in there, so I want to let some other people ask. Corey Showers asks, should we build microservices by doing synchronous coupling using REST, or should we use event-based async between services like RabbitMQ or other async methodologies?
Great question. So, oh boy. I think you'll see in the next revision, the next sort of major update, that one of the themes will be bringing in Spring's amazingly good support for messaging and integrations, be it through the Spring Framework proper primitives and Spring integration for just that, right? So yes, we of course think that messaging is a hugely important way to communicate and to build services. But for a lot of people, REST is just fine. There's a couple of places where you're gonna lose time. It's if you have a long running task, then you're not gonna want to use the REST because you're gonna keep the client blocked. But again, you might be okay with that. It's actually the real cost is, are you keeping the server blocked? And if you're using asynchronous I/O, then you're not. The server is going to do background processing. Wherever it does it, it's fine. And indeed, the REST request could spawn a message. It could use, for example, a Spring integration gateway and send off the processing to some backend grid of processing nodes, and you can get the response asynchronously, and then send the response using asynchronous I/O. And you can do that right now. And in fact, that's easy enough to do just with Spring Framework and Spring MVC. But there is now already support for, if you look in Git for Spring Cloud, there's initial cuts on being able to send back an observable from RxJava directly from Spring MVC endpoints. So again, if you want to run that processing code asynchronously and not monopolize threads, that's what a lot of people are looking for when they go to messaging. Messaging does add another moving part. It adds a broker, and the question is, well, what broker are you going to use? RabbitMQ is a fine choice. I just put a blog out 4 days ago or something like that on using Apache Kafka, which Netflix use heavily for a lot of their stuff, for something like 300 billion to 800 billion messages per day. So again, there's a lot of different, very, very, very cloud scale capable message queues out there, and you can tackle some of those problems now. Whether it's the best choice, again, I guess I'm just trying to say it sort of depends on what you're trying to do. If you're trying to get queuing and you need to have guarantees there, then maybe the message queue is the right way to go. If you're just trying to get asynchronous, temporally decoupled calls, then you can get a lot of that just from asynchronous I/O, which you can get today. So, I don't know. That is definitely something we're working on, though. That we want to. Yeah. If you have use cases you're particularly interested in, please GitHub right now, github.com /spring-cloud. We are mulling this stuff over right now.
Yep.
This is a big theme.
Excellent. Hey, Ken Kruger, how's it going? I see Ken Kruger popping up, asking if you could review the dynamic port selection. There was some code that selected, $port, $server port, 0.
Right. So
I think you were saying 0 was like the port randomizer, right?
Right. So yeah, it's server.port 0 will randomly select a port that's available. What I had was, I'm using the property placeholder resolution. So let me see, Bootstrap. Oh no, it's in here. In the application.yaml, what I had was doubly nested property placeholder resolution. So it could be port 0 that says if the port variable is there, use it, otherwise use 0. But I said instead, if it's there, great. Otherwise, another property placeholder resolution. If server port is there, use it, otherwise use 0. So it's like, if this, else use this, if this, else use that. I'm pretty sure, though, that Ken already knew that, given that he knows all the things. So did I misunderstand the question, Ken?
No, I don't think so. He's probably just pointing out because it might be a little bit of it's a convention over configuration, right? And if you don't understand the convention, then people might not miss it.
I think maybe he's just trying to tell me he didn't think I covered it clearly. That's a good point. Yeah, I should have been a little bit more in detail. If I, as usual, Ken, love you, man. Send me an email if I can do better.
All is well, my friend. All is well. Oh, by the way, Ken commented, and he felt his opinion was that the heavy rate reference refers a bit to jar size, but also runtime memory consumption.
Yeah, that has nothing to do with Spring. You can do terrible things with a screwdriver,
Yep. And cloud, I think at the end of the day, memory and disk on the cloud are pretty expensive. So I mean, there's
even that. I don't buy the argument. I mean, there's no reason it has to be. All of these services take less than 250 megs of RAM. All of them. Everything I've shown you here. So not together. I mean, each one is less than 256 megs of RAM. So again, I don't know.
Alvaro Ruiz asks for a little more explanation on the load balancing bit for Spring Clouds, which is a ribbon, I think, right?
Yes, sir.
Okay, cool.
What do you want to know, my friend?
He wasn't anything in particular. He just said he just asked for a little more explanation. He didn't. So maybe just a quick high-level review and call it and move on.
So ribbon is configured by Spring Boot. Load balancer auto configuration. There you go. We configure the REST template. Remember I showed you the REST template actually has the ability to make calls that are load balancer and Eureka aware. That's actually done right here. REST template, blah, blah, blah. Pass in a list of interceptors, right? And we're going to inject the load balancer interceptor, which is the custom one that we've developed here. The load balancer interceptor is going to need the load balancer client. The load balancer interceptor is the thing that's actually going to call into ribbon, which is the load balancer client object here, right? And it's going to ask it to find the appropriate instance for us. That bit in the ribbon auto configuration, we actually configure that here. We configure ribbon load balancer client, and the ribbon load balancer client is where all the magic happens. So if you want to override things, if you want to change things, this is where you would do that. Here we go, choose. So what we're saying is get the server. Let's see, for a server ID, get load balancer. Let's see, load balancer, choose server, finally. Okay, so at some point in this chain, there's here we go. Chain, ribbon server, blah, blah, blah. There we go, execute. I think this is the bit where we drop down. So the client factory, get load balancer client, get the server, open the connection, get blah, 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 request apply, passing in the ribbon server. So I think that's actually that's actually where we get the decision on what we want. And you can override what is used, right, by specifying your own load balancer, iLoad balancer in this case. So the get load balancer here is going to say client factory get load balancer for this given service. And then that's going to say get instance. And then that is going to look for beans in the context of the type, or in this case, iLoad balancer. So if you configure those, it'll use that. Otherwise, it'll delegate to this config thing, and this is where I get a little lost in the code. But the point is, this is all well documented, and it's all happening in here. And what you're basically trying to do is to configure instances of iLoad balancer at some point, right? And that's where did I say iLoad balancer? There we are. Here are the ones that come out of the box. There's an abstract one, there's a base one, which is common. Dynamic serverless load balancer is the one that we're using in most of the code. By default, this is the one that takes a collection of service instances eventually. There's a no-op one that just does nothing. And then there's I think it's an Amazon Web Services zone aware load balancer as well. You can, of course, implement your own, right? So you have a lot of choices here. You can easily do the right thing if you want. And the decision is entirely arbitrary.
Awesome. Thank you, Josh. Much appreciated, Alvaro. Hopefully that helps. Let's see, there's a couple more questions, and I think we actually might have a shot at draining the question queue. But let's see. Pedro Alvaro asks, what are your recommendations with regards to choosing between, actually, you know what, we've heard a little bit about this. Hold on, I'm going to park that question for one more second, because there's a really good one. Where did it go? It's on security. Yeah, basically, I think you touched on this a little bit, but just basically, a gentleman named Barathi was asking how the security between the services is handled, and you started to touch on that a little bit with auth tokens and OAuth, right?
Right. Yeah. So I would encourage you to take a look at Spring Cloud Security, which builds on top of Spring Security OAuth. Spring Cloud Security makes it dead simple, super, super simple, to stand up a identity provider, basically an authorization server that is based on OAuth. It'll create and serve access tokens. So it'll say, you can have an application with it'll have a challenge, an authentication challenge. The application challenge will be forwarded to the identity provider, like the authorization server that serves authorization tokens. And if it's valid, the authorization server will give out an access token, and then all of the different microservices can point to that authorization server and say, you need to get an authorization server from this service, and they'll know to automatically redirect to that authorization server if there's an invalid request without an access token in the body. again, you can use Spring Cloud Security's OAuth-based identity server, or you can just point to, Facebook or GitHub or whatever. You can use somebody else's OAuth identity server. But the result is that you have a suite of services with one annotation and a few config properties, basically telling it where to look for the endpoint that can be used to decrypt an access token. And that's it. It'll automatically, every protected resource will automatically know to call this authorization provider, this identity provider, and go through the flow of getting an access token. If you want to learn a lot more, I cannot more emphatically recommend it. But if you want to learn a lot about this stuff, don't hesitate to check out the good Dr. Dave Sires' amazing 7-part now blog series on single-page apps with Angular.js and Spring Security and Spring Cloud Zool and Spring Cloud Security and Spring Session, and just awesome. He started back in December, and it's been phenomenal. So if you want to learn about that, it's a great way to go. And he talks about Spring Cloud Security.
Yep, there's a lot in there. That's great. Thank you very much. Awesome. Okay, so Pedro, a couple more questions, and I think we're going to cut it at the half hour here. Jorge Lee asks, how easy is it to override those YAML configurations for automated testing?
Very. So again, if you saw in the beginning, when I created that Groovy application, I specified on the command line here.
Sorry, and he goes on to ask, just so you hit the same, because it's just you hit the same topic at the same time. He's also curious, how do you swap the config based on profile or environment settings? This is kind of where he's going with this whole
right.
thing.
So if you want to override individual little properties, again, you can do, for example, Java -d server.port equals 8000 -jar, whatever, right? Or hi.jar, like that. You can do things like that, so that'll be -d arguments, or you can say export server_port equals 9000, and then do Java -jar. That's certainly going to work as well. You can also, as far as profiles are concerned, in your config server, store, for example, bookmark-service-cloud or dev or whatever, and that'll be loaded based on the profile that's active when the request is when the application starts up. So it'll load the right configuration file based on the profile in the running client application. So I think that's probably what you're looking for.
Perfect. Let's see. What are your recommendations with regards to, again, we heard this on the last webinar, Josh, right? What are your recommendations with regards to choosing an implementation for service registry? Consul, Zookeeper, Eureka. Say if you're just getting started with service discovery and such.
I would start with Eureka. It's darn good. It certainly works at scale. It's being used by Netflix. It's easy enough to stand up. As you can see, it's just an annotation and a dependency import away from working. So I would start with that. It's definitely the most friendly to get started with. Consul is by the same folks who built Surf and Vagrant and so on. It has some really, really smart features. It's written in Go, so it does impose a slight bit more deployment complexity. But again, I don't think that's really a problem for most modern teams. It has some really, really cool features. So again, that's worth checking out. But if you're looking for just a straight up, very, very simple service registry, it's hard to beat Eureka. Zookeeper can do, it's actually using it as a service registry in the same way that we might use Eureka is a disservice to Zookeeper. Zookeeper is actually capable of a lot more, right? It actually has its niche is coordination information. So you can, for example, handle very, very weird specialized topologies and handle, for example, situations where, for example, a node may go down and you want to know, you don't want to have the split brain problem, and you want to make sure that if a service is the master, then it's either you evicted from the cluster correctly or whatever. I mean, you have a very a lot of power there, and it's actually a set of low-level primitives. So while Spring Cloud can treat it and use it as a low-level service registry just fine, it actually has a lot more power. That one I would say I would tackle that one if you're not entirely satisfied with the other ones first. That one's really powerful. It certainly works as well. It's at scale. I mean, we use it in Spring XD. Apache Kafka uses it. We have preliminary support, not just for using it as a discovery engine, but as a service broker, but also as a framework for dynamically electing certain nodes as leader, for example. Certain roles. You can say, okay, well, if my node gets elected as a leader, publish an application event, for example. So there's a lot of really powerful things you can do there, and that's actually code that's in GitHub right now that you can poke around at. And if you have use cases, we're always very keen on hearing those as well. That's certainly one of the things we're focusing on, the more complex interactions there. So yeah, I don't know, good stuff there. And of course, you may not need a service registry. If you're running inside of a Lattice, for example, you can use the Spring Cloud Lattice project, and that'll give you a discovery client implementation that'll use, because again, Lattice knows which API, which node is running which application, and that is to say, which service. So you can ask it in the same way you could Eureka, for the service ID, give me the hosts and ports. And the same thing for Spring Cloud and Cloud Foundry. That supported on the way too. So, maybe you don't need it, or maybe, and there's no reason you couldn't use, for example, Eureka on top of Cloud Foundry. Indeed, we're actually standing up push button deployment of Eureka on top of Cloud Foundry. But again, maybe you just want that mapping, and that's already maintained by the platform.
Okay. Whew. All right. So the questions are continuing to come in, but I think we're going to have to call it. It's we're 30 minutes after, and we usually really try not to go any longer than that. And we're down to only 100 people now, where we had a couple hundred before. So I think we're pretty much at time. Great to hear from you too, Ken Kruger. Yep. Yes. So. Just a quick bit of housekeeping. We are recording this, and it will be posted, right, to spring.io/video. Again, spring.io/video. Yes, we always record. Josh posts his slides up to a speaker deck, and then the slide link will be in the blog post. So again, if you want to get a notification when when the replay is available, just go to spring.io/blog. And subscribe there to the Atom feed, and that's a great way, because when we post the replay, we always make a blog post that embeds the YouTube video, and that'll have all the information you're looking for. Sorry, my machine is kind of freaking out, so I'm missing a little information here. Hang on one second. Yeah. In the meantime, on April 28th, come back and join us. If you're interested at all in Apache Kafka and high-speed messaging type stuff, like Corey, like that gentleman Corey was, you should come back on April 28th. The Spring XD team is going to be talking about Apache Kafka and doing reactive data pipelines with Spring XD and Apache Kafka. So. I think it was Corey. You might be really interested in that one. I'm going to attempt to post the blog here. Hang on, I just kind of lost the chat window. Hold on one second, folks. Let's see. There we go. I hope that worked. Josh, did you just full screen?
Yep.
Okay, all right, that's okay, got it. I'm missing. Oh, cool, yeah, and Corey says excellent, thanks. Okay, Corey, yeah, it's...
Don't miss that webinar, by the way, folks. Marius Bogovici and Dr. Pollack. That's awesome.
Sorry, the formatting is coming through all weird. Hopefully that's enough for you to get it, Corey. Sorry about that. Hang on, let me try one last time with this URL. The formatting guy, it kind of introduced some line breaks there and got messed up. Let's see if that works. Oh, come on. Yeah, it just doesn't. Sorry, the line breaks it's introducing are not going to make it copyable. But yeah, great. Thanks, Corey. You got it. Awesome. So, by the way, if you want to get your hands on bits, just make a note that we don't really encourage you to direct download Spring Bits by HTTP direct. We really want to encourage you to use Maven and Gradle, as it's just better. If, however, you're stuck behind 9 layers of proxy servers, or you work on a military network or closed government network or something like that, you can get HTTP downloads. We just don't make it super easy, to be honest. And those are available at repo.spring.io. If for some reason you need a direct HTTP download, really encourage you to use Maven, or if encourage your organization, best case, to set up a private Maven on your network so that you can use it. And let us know your feedback. The Spring Cloud team would love to hear from you. If you want, you can tweet any of your feedback back to them at Spring Cloud OSS. That's right there in the chat. And yeah, like I said, there will be a blog post for spring.io/video with the replay and the slides. So again, let's hear it for Josh Long for an incredibly detailed, awesome presentation on a really difficult topic in distributed computing that we're working hard to make easier for you guys. So, Josh, thanks a lot. I learned a lot from this presentation.
Thank you.
Did too. Anything you want to say before we close it out and call it a day?
No, thank you guys. See you online.
All right,
Enjoy.
Awesome. Take care, everyone. Appreciate your time and your questions. Look forward to seeing you on April 28th at the Kafka webinar. Take care.
Yeah, that'll be great. Don't miss it.